Welcome to Under the Radar, a show about independent iOS app development. I'm Marco Arment.
And I'm David Smith. Under the Radar is never longer than 30 minutes, so let's get started. So today we wanted to dive into everybody's favorite pastime as a developer, and that is debugging. It is a topic that I think we probably... It's kind of weird in some ways, because I think I probably spend at least half, if not a majority of my time in development debugging code that I write. Yet, in most of my actual formal preparation for being a software engineer, there was very, very little time and attention spent on it. Like almost all of my classes and things were all about focused on the actual development and the architecture side of things. Whereas the reality is we spend most of our time, fixing the problems and issues that arise in our apps. And this, these can range from all kinds of, to different levels. There's the kind of while you're developing debugging process where, you write some code, you hit build and run and you see if it works. And if it doesn't, you try and work out why. There's the sort of more subtle, something happens every now and then and you're not really sure why, and you try and track that down. And then there's the, you getting crash reports or bug reports from customers in the field, and then you have to try and track those down, which is even more exciting and challenging. But in all of them, I think there's an element of, debugging is essentially you sort of identify that there's some problem. You then try and reproduce that problem in a way that you can then observe that problem. Then you try and isolate where in the actual, program that is happening, and then you can try and fix it. And you kind of go through this cycle of, you identify it, you reproduce it, you isolate it, and then you can fix it. And you kind of cycle through that. Or at least that's the process that I tend to take, because if I don't go through each of those steps, I find that it's very hard to actually make progress. If you can't, some bugs really are by their nature kind of hard to reproduce. And if that's the case, it's still a bug and it's still problematic. But, if I get a bug report that I can't reproduce in any way, it's just as the same in some ways as not having that bug report in the first place, because I can't do anything with that information if I can't reproduce it. So, my first step is always, let's reproduce this. And then, let's try and find the part of code. And I think having been a professional developer for enough years now, I feel like I have a better sort of sense for where the bugs might be hiding. It's like I've seen not every bug, but I've seen a lot of bugs before, and you kind of get this sense of this looks like this is an off by one error. This looks like this is a cache invalidation error. This looks like, I'm writing something incorrectly here, or I forgot a case in a switch statement. You kind of get this feeling for it, and then you can kind of go running around trying to find it. And then, of course, there's also, I guess, the other kind of debugging, which is even super fun, which is where there's a bug in the OS that where your code is all doing the right thing, but then you're getting weird results, from the OS. And so that's an even more fun line of debugging, where you kind of get this sense of you keep going down and farther down the rabbit hole until eventually you're hit a brick wall at the end of it. And you're like, all right, well, I guess I file a bug.
Yeah. And that's, it's often easy for us to jump to, well, this must be a bug in the OS, or my favorite one, this must be a bug in the compiler, or something like that, right, when we can't figure it out. That is, for the vast majority of bugs that we face as programmers, that is almost never the case. First of all, you are unlikely to ever have a bug in the compiler actually affect you. And, as you go up the stack of, things that you're relying on, the OS does have bugs. Libraries that you're using will have bugs. But if you run into something in your app that seems like a bug, and you are tempted to blame the OS or a library or something like that, really make sure that you can't figure out that it's your bug first, because chances are very, very good it's probably your bug. The vast majority of the time of those cases, it will really be your bug. It's only a question of whether you can find it. But don't just say, "Oh well, it's a bug in the OS. I guess I got to just deal with this or move on or yell at them." Really make sure it's not your bug first, because again, the odds are strongly in favor of it being yours.
Yeah, and then because the reality is, most of our time, at least in my experience, dealing with bugs, it's almost always something I forgot to do or a case that I forgot to consider when I was originally doing it. Like, and not necessarily out of like laziness even. Like sometimes it's that, sometimes you have the always classic, like, you see an example where it's like, if error doesn't equal nil, then do something with it. It's like, and then if you don't actually do anything, when eventually you do run into the situation where the error is not nil, then all of a sudden things break. And, that there's that kind of laziness. But more often it's just like you forgot to do something and then it comes back to bite you. And I feel like I think there was a, one of the, maybe have been an XKCD cartoon about this, where it's sort of the stages of debugging where you go from like, it's like, oh, it's you get a bug report and you're like, oh no, that can't be right. I'm sure my code is good. And then you kind of like, oh no, it's actually broken. And then you go to the like, how did this ever work phase?
Yeah.
You're like, how on earth did this even work? When you cause it's amazing how when you look back at your own code, this is code that you wrote with your own hands on a keyboard. You put this into Xcode, you come back and look at it and you're like, how on earth, what am I doing? Like, and I feel like that is the hardest part or why debugging is so hard is you have to recreate all of this sort of state and information that went into the creation of the code, hold that in your mind, and then run it through a scenario that's happening, and to then see why it's doing something weird. And very often I find like the hardest thing is to try and understand even what the code is trying to do in the first place, or like why there's this weird exception, that was introduced there, years or, decades ago. And you're like, I wonder why I did that. I don't know anymore. And that's, makes debugging really, really hard.
Yeah. And this is, it's also a major argument for keeping things simple and not that clever in the first place. And as we've talked about, I think a while ago now, like I try to avoid overly clever code styles, things like using really dense shorthands or really clever mechanics, things like generics in like Swift, like that kind of thing. Like where you kind of use like overly clever complex language features or constructs where it looks really cool and you feel really smart when you do it, but when you have to come back and debug code, in 6 months, and you have totally forgotten what led you to write that, and you've forgotten the cleverness behind it, and you have to figure it out by looking at it or figuring out by its effects. It's often very, very hard to do that, and you often as a programmer you might eventually hear the wisdom of like, write code for someone else to read, but really what you should be doing is writing code for yourself in 3 weeks to read, because you will have probably forgotten by then why you did what you did. So if you keep things simple from the beginning and not be too overly clever with the way you write things, and make things straightforward to read and to kind of self-document, then you will be doing yourself a huge favor. Documentation, separate documentation can help with some of these things, but I've found in practice that maybe it's just me. I don't document things that well. I try to just write things that are obvious when you look at them, and that just have good names and straightforward approaches, and that tends to work very well. And that can never be out of date because it's the code itself. And then for minimizing bugs to begin with, I think it's again very important not to be too clever and to realize. For me, many of my bugs come from quick workarounds or quick hacks that I do when I encounter some other bug. and so one great example of this that I'm sure many iOS programmers face is whenever you're doing something in like a launch loop or in a UI response loop or something, and there's some weird behavior or some weird precondition that you can't quite accommodate in a straightforward way. So you just dispatch async to the next run loop of the main queue, and you say, all right, dispatch async onto main queue, do this thing on the next run. And that's a really nice, quick way to avoid a lot of like, weird complexity or obvious bugs as you're developing. But I have found in almost every case that using a dispatch async is almost always a bad idea. like when you're just like kind of deferring work till later on the main queue or something. Like obviously there are uses where it's fine, but like what if that's your approach to solve a problem? Then you get into concurrency bugs and weird conditions there that are really hard to fix and diagnose and reproduce. And it again, it's like one of those areas where it seems like a clever thing when you're writing it. And in the case of like bug avoidance, like it seems like, oh, this will be a quick fix for this weird little bug. I'll just wrap it in dispatch async and that will fix the problem. But then you introduce all these weird other problems that might be non-obvious, and those become very hard to debug. So in addition to keeping code simple as you write it, for the purposes of debugging, I also would strongly recommend avoiding concurrency if you can, and avoiding playing with threads and queues when not necessary or when not warranted.
Yeah, because I feel like what you're doing there, I mean, and I'm very guilty of that. Like I have done the dispatch async fix probably 100 times, 200 times in my career, like all the time.
And I cannot overstate how many bugs that I've had to fix end up being a poorly used dispatch async.
Yeah, because I think the reality is what you're doing, and this is maybe a maturity thing, but it's the understanding that like when I do that now, I understand that I'm not fixing the problem. I'm changing the bug from whatever it is. Say I have a bug that happens, 1 out of every 100 times the app runs, and that's a problem. 1% of users are hitting this issue. I wrap it in dispatch async. What I'm doing is not removing that problem. What I'm doing is changing it into a like 1 in 10,000 bug, which is better, but also incredibly difficult now to actually like properly fix and diagnose and reproduce, et cetera, et cetera. Like it is the kind of fix where it isn't actually solving it. It's just making it less likely, which sometimes, pragmatically, I'm sure there are many places in, my shipping apps where I have that. And it's just it's like a conscious choice that you're just like, well, the actual fix is too hard or would require a massive refactoring or some kind of, thing where you can make this trade-off and choice. And you say, like, I'm just going to fix this by patching it. And I know that what I'm doing is going to cause a problem for me down the road. I know that this bug hasn't magically disappeared as a result of this, but like, it's a conscious choice. And that's a balance. But yeah, ultimately, most when you're writing the code, you're kind of trying to do your future self a favor as much as you can. Because I think one of the things that I struggle with too when I'm writing code is the realization that all of these things that seem obvious to me when I'm writing the code, because I'm in a mindset where I'm focused entirely on whatever the solving this problem is. Like there's all these things that just seem obvious. Like, of course, like this is the way this works. That's why this is set up this way. This value will always transform from this to this. Like there's all these things that seem obvious. And then in the future, they're entirely non-obvious. And I think the biggest difficulty I have with things like documentation is that it's kind of impossible to know what your future self is going to want to know, because everything seems obvious and kind of trivial in the present. And so, like, I think I'm kind of like you. Like, I tend to only document code in my apps where I'm doing something that is clearly weird or like strange, where you have some kind of magic number that you have to introduce into something where it's like, why am I multiplying this value by 1.632? Like, there's a reason for that. And if there is, like, that's the kind of thing that you write down. But otherwise you end up with like writing your program twice if you're overly documenting it. So as much as when I'm debugging, I kind of wish my past self had written all this stuff down. The reality is my past self wouldn't actually know what I need to know right now, because if they did, they could have just made the code more obvious or clear in the first place, probably. Or at least that's what I tell myself.
We were sponsored this week by Pingdom. Start monitoring your websites and servers today at pingdom.com/radar. You'll get a 14-day free trial, and when you use code RADAR at checkout, you get 20% off your first invoice. Pingdom is a wonderful monitoring service. They are focused on making the web faster and more reliable for everyone who has a site. because they offer powerful, easy-to-use monitoring tools and services. So if you're a Pingdom user, you can monitor the availability and performance of your servers, your databases, or your website, and it's so easy to do. They test from more than 70 global test servers, and they can emulate visits to your site as often as every minute. And they can do cool things like cookies and logins and everything else too. Because, these days, websites are becoming more and more sophisticated and very often include multiple different parts with several different dependencies. Maybe you depend on an external service, or maybe only the login screen does this one thing in your code. And you need to check all these things, and you can do all that with Pingdom, and loads more in addition to that too. They can make it possible to monitor the availability of all these key interactions people have with your site, because a lot of times it's more complex than your site is up or your site is down. So, stuff breaks on the internet all the time. Pingdom knows this. They detect around 13 million outages a month. So regardless of whether you have a small website or you're managing a whole infrastructure, it is very important to monitor the availability and performance. And Pingdom, when it goes down, they alert you in any way you want. You can have text messages, you can have push notifications, emails. It's so configurable. We've even used it in the past to monitor other people's websites. Like David and I have both independently used it to monitor the WWDC page for changes. Like in the past when it was really important to know when WWDC tickets went on sale. I've used Pingdom for a very long time. Highly recommended. Check it out today, and you will be the first to know when your site is down or being too slow. So go to pingdom.com/radar for a 14-day free trial and use code RADAR to get 20% off your first invoice. Thank you very much to Pingdom for their support of this show and Relay FM.
So the other thing that's probably worth diving into a little bit too is the way in which we actually do debugging, because maybe it's a shocking revelation, but I believe what is technically called a Caveman debugger.
The printf debugging?
I do all of my debugging using NSLog and the console, which I think is often disparagingly referred to as Caveman debugging, which is fine. I'm sure there are better ways to do that. And I mean, every now and then I'll go to a WWDC session where they're talking about all the crazy things you can do in Xcode, where you can set conditional breakpoints and all this kind of really clever stuff. And in the end, what I always do is I end up just NSLogging tons of data to the console, because it's one of those things where most of what debugging is trying to do is, it's like you're trying to unwind the state machine that is your app, or you're trying to work out, it's like your app is in this you're in a good state, then something happens and you're in a bad state. Like that is, at a very high level, that is what a bug is. And what you're trying to do is identify that, what point it's going from that good state to that bad state. Like what is happening there? And I've been professionally developing for 17 years now or something. And I still like that. The most effective and powerful tool is just NSLogs everywhere. And you get kind of good at it. Like I can identify and find things fairly quickly this way, because you kind of get the sense of, you're trying to isolate where in the code it's happening. And so you'll end up putting NSLogs, in different parts of your app that you think might be part of it, and trying to work out which one's getting, which code is getting hit when you do it. And then something that I also find really helpful, is when I format my NSLogs as, tab delimited text. So like often I'll have like several variables that I'm trying to observe and watch, and I NSLog those as a tab delimited set of strings, because then I can take the output from the console and I can copy paste that into Excel, and it'll put it into columns for me.
Oh, that's interesting.
And you can then you can take that data and then look at it over multiple runs, and you can start it's a way to actually make the data, make it into something that's useful and like. At least for me, in the way that my mind works, that's how I debug the best, is when I'm taking this data, I'm taking something out of the console, looking at it often in Excel, and then kind of finding the pattern, finding the thing, and then I can actually go and fix it. And like, I don't know if that works for me. I sometimes feel bad about it. I feel like they have all these really powerful and clever tools, but the reality is, I think the hardest part too is that so much of so much of debugging is the hardest part is often the reproduction part, and getting everything, like it's hard to observe these issues sometimes. And so like the nice thing about a console log is that you can have those running without being attached to the debug server, for example. Like you can have that, you can create these situations where these things happen. Sometimes it gets really awkward to have your app attached to the debugger. Because sometimes when it is attached to the debugger, the bug goes away. Like there's lots of weird situations and issues where NSLog debugging is the best, but I'm very aware that by doing it that way, I'm not taking advantage of more sophisticated tools. But I know for myself, like that's what works.
Yeah, I mean, and there's also there's lots of different kinds of bugs, and a lot of these different methods are more or less suitable to different ones. Like for example, NSLog debugging, which I do a lot myself, it's not necessarily the best option if you have like a kind of nitty-gritty like code level bug, like this function isn't always returning the right value. Like for that, I prefer to use conditional breakpoints, so I can see whenever this value is something out of whack, stop here, and then I will inspect the stuff around it. But NSLog debugging is a lot more helpful for things like larger systems interacting with each other, any kind of large operations, concurrency, things where like you're not really sure where the bugs might be, but you just kind of want to get a good idea of what is going on in the system. It's also, NSLog debugging is also very, very helpful in situations in which the debugger itself is impractically slow to do things. So a lot of Swift context, this is the case from what I've heard. It's also very much the case when you're debugging on device on the watch. Because then the round trip between your computer running Xcode and the phone and the slow watch hardware, like trying to break watch apps, like with breakpoints and inspect local variables around and running things in the debugger command line is so slow on the like when doing things on the watch that sometimes it's better off to just do something, do it a different way, do printf debugging or whatever else. For me, it's also I also debug very differently if I'm looking at a crash report versus some kind of behavior in the app that I'm catching live. It's very important to look in iTunes Connect and to look at rather, I guess now it's in the organizer in Xcode, to look at the crash report that Apple's getting for you. Look at what's being gathered there. There's a whole lot of different problems that your app can have in the wild, and the fact that we can get our apps, or that we can get our crash reports basically all the time from Apple, that like whenever an app crashes, we get notified about that. That's pretty awesome. And there's, of course, also lots of different other services as well. But there are some types of crashes that only Apple's crash logs will generally reliably be able to report to you. That includes things like if iOS kills your app for some reason that isn't necessarily a crash, but if your app is getting killed in the background or something, or if your extensions are getting killed, then that's things that iOS can provide very useful feedback to if you look for it. And that's all in the Xcode organizer. And one of the things I can recommend highly is look at those. And a lot of times the organizer won't tell you, like, if you get, like, I was just spending a lot of time debugging crashes in my Today widget, or my widget, I guess. And if you look at just the crash log, it's not very helpful in the organizer. But if you right-click and show in Finder on that crash, and you dive into the bundle, and you can get the raw crash logs that are inside of that bundle, when you look at the raw logs, you can get a termination code. And a lot of times that is Springboard telling you something. And there's a great technical note, TN 2151, Understanding and Analyzing Application Crash Reports. And this tells you all the crazy codes that your app might be killed with. So one of the things that I was facing is my extension was accessing the SQLite database in the shared app group container. I don't recommend doing this now, but now I know better. But if you're accessing an SQLite database in a shared container in an extension, at the time that the OS suspends you, it will kill your app with a certain code that says deadlock in hex. And if you didn't look at this document, and if you didn't find that crash report and find that code, and if you didn't then look at this document to see what that means, and it tells you right here, it's been terminated by the OS because it held onto a file lock or SQLite database during suspension. And I didn't, and before I found all this out, I just didn't know why my extension just kept crashing for everybody, and people kept reporting things like, hey, your app is crashing in the background for some reason. I'm getting all these logs on my phone. What's going on? iOS tells you these things. Like, it's telling you useful information here. And so if you look at those crash logs in the Xcode organizer, and if you look up what these different termination codes mean, you'll probably find out something useful. And this is all like, and we have wonderful things like, if you're kind of wondering whether you fixed a rare crash or not, you can look at the analytics section of iTunes Connect, and it will graph for you how many crashes per day your app is having, and you can and it marks on the graph where your updates occur. So you can say, oh look, when this update was released, the crashes dropped by half. So the thing I fixed, I probably the thing I think I fixed, I probably did fix. There's all sorts of useful things you can get from crash logs and things like that. And one of the reasons why I do also, as I said earlier, kind of recommend against unnecessary use of dispatch async is because that makes your crash logs less useful to you. Because usually the crash logs will not report where the block was dispatched from. Some of the more advanced ones like Hockey try to do this, and they have mixed degrees of success in my experience. And so if your code is simpler, then any crash log you get will also be more useful to you.
Yeah, and I think crash logs are definitely like a great source for so much of this stuff. And I feel like, in general, I will say that Xcode, as much as I don't use all of its tools, like some of this stuff that you're talking about of going into the organizer, like there's some really useful tools that we have at our sort of at our disposal to be tracking a lot of this stuff down now, which I don't think we had before. I mean, it makes me think even of one of the other tools that I use a lot in debugging in a strange way is version control. And specifically, git blame is often incredibly helpful in trying to track down weird situations in my apps where, code is doing something weird and I'm trying to work out why I structured it in the way I structured it. And this is something that I love in Xcode, where you can go into the top right, where you go into the source control thing and you can do blame, and it will show you all of, for every line of code in your app, it'll show you which commit that line of code was introduced into your app with. And so often what will end up happening there, it's like by using that view, I can see like, that's weird. Here's this one random line of code that is left over from an old version that everything else was updated, or, situations like that. And, Xcode is really, and then you can, I think if you double click on it, it'll show you that commit and it'll show you the relevant, how that file changed with that commit. And that's another example of one of these little tools in Xcode where it's like, it helps you understand what's going on in the same way that, that's a really great one. And I mean, I love in their crash logs where it can help you take you right to where the crash happened, rather than sitting there and, trying to, work out which, if this crash happened in this, in this file on this line number, I mean, that's useful, but it's way more useful to just take me to that line number. So there's definitely some great tools in Xcode that I think make a lot of debugging a lot simpler, and that I'm very grateful for.
I would also say when you're running your app and you're trying to figure out maybe what's going on with a bug, always watch that pane in Xcode that shows you the running CPU usage and memory of the app. And of course, you can go into instruments and get, like a more fine-grained version of this. But like yesterday, there was this really tricky bug that I could not figure out. Like the app just started behaving really weirdly when loading episodes of a certain podcast, and it like really weirdly. And it would eventually disconnect from Xcode. It was a massive, massive weird bug. And Springboard would crash. And what led me to the solution was that I happened to be glancing at that pane that was showing me the resource graphs in Xcode during one of the runs, and I noticed that right before it crashed, memory usage skyrocketed all the way up to like a gig, and then everything freaked out and blew up. And so then I was able to say, hey, wait a minute, that's unusual, that stands out. Let me run it under the allocations instrument run that can show you where all your memory is being used. And I did that and figured out what the bug was within like a half hour after that. This is a bug that's been bothering me for weeks. I couldn't figure it out. And then within a half hour of noticing, hey, this thing is out of the ordinary on the memory meter here, I had to fix. So use the tools that are available to you when appropriate, or just use NSLog and printf debugging everywhere.
Yeah. And I mean, what you hit on there, though, is one thing that I will say that I love about debugging is that so often you get to the end and there's like a relatively straightforward solution, that fixes the problem. And like, that is one of the greatest joys of being of software development. When you like, you see the problem, you see the solution, and you can implement it, and like, it's gone. And this thing that was problematic and hurting your users is now just completely vanished. And like, that's like a great victory. And I always love when that happens. It doesn't always happen, but when it does, it's absolutely awesome. So it's the one reason I love debugging.
That's why we do all this, right? That feeling when it finally works. We're like, yes, I love that feeling. All right. Thanks, everybody, for listening this week, and we'll talk to you next week.
Bye.